Okay, so we will continue with the Gretl session. So I am opening Gretl. Okay, I will come to the data set and other things later. Now, everybody knows how to install Gretl, right? You go to the Gretl website, and from there you can download Gretl, the latest version. It is always better you download the latest version, and it is given in 64-bit and 32-bit. So according to your computer type, you download the relevant one, 64 or 32, and then the downloading and installing will take less than 5 minutes, and you will get this one. And first you have got this window. You go to the help. Here you have the usage guide. This is the manual, Gretl manual. So you click this.
Sir, please go to full screen mode of this window.
If we go to the full screen also, if we go to the full screen, the letter will be the same. See, there is no change. Got it? That is why it will not change. Otherwise, we have to go to the settings and then change everything. I don't know, by changing everything, it may not. I think it will not, because I have tried that. These are already given. We cannot increase the size. So we can open the Gretl uses manual, uses guide, and you can read this. You can learn a lot of theory also, and also how the programming can be written there also, because they are using they have their own console, and they are using the commands in the console, and then doing it. So you read this, and in Google, that is principles of eating. Okay, that particular the PDF copy is available in Google. So you type think Gretl, you will get that. So you can go through that textbook also. It's a big book. You can learn everything in Gretl. So these are the two sources that are available. Then again, go to the help and packages. This one. So click this. Gretl is an evolving software. Evolving in the sense that just like R, new programs are being added to Gretl, like R. So the new programs you can find in here. For example, this one server. Click this one server. You should have an internet connection, then only it will work. So click this one server, and you will get a large number of new programs are being added. I have already updated all the programs. That is why it is given up to date. Otherwise, it will be given not. For example, see this one. This is a new one, not up to date. That is co-integration with the receiving sheets. This is not up to date. So in order to install this one, we go to this button. This is install, this button, and click this one. So we click it. I think there is some problem, and this happened earlier also. I don't know what this means. So it is not, there is some problem in installing that particular package. Anyway, this is how we can install or update all the programs like this. So click this one and then go to the install button, click it. Then here also there is some problem. So it is not possible. This also not up to date. I don't know whether I have done it earlier and there was problem. Okay. See, so this is a new one. It says installed. Sometimes some question may be asked whether you want to install this and install this in Gretl window itself. So you say yes, so that that particular program will be available in the Gretl window itself. So you have to make all these up to date. So this is one thing that you have to do once you have already installed your Gretl. Now I shall tell you some important advantages of using Gretl. One thing they see, except file, tools, and help, all other menus are inactive because we have not entered the data. Once we enter the data, all these buttons will become active. Now, if we go to the tools, then here we can have statistical tables. That is, see, for example, I am clicking this one. So we can have the normal statistical table, that is the table value T, chi-square, F, binomial, Poisson, V-bull, and DW. Now, for example, for the normal distribution, mean 0 and standard deviation 1, we can give any number here, depending upon our estimation. And we write the right tail probability. For example, 0.05, 0.05. I'm writing 0.05. Then what is the corresponding standard normal distribution value? That is the critical value for this one, 0.05. Click OK, and we get the answer here, that is 1.65. This is the critical value, 1.65. So similarly, for all the distributions, we can have the critical values corresponding to the right tail or left tail probability. Then we can also have the p-value finder. That is, once we have a particular estimated value, then the corresponding probability we can have. Suppose we have estimated a regression coefficient and its value is 2. Suppose. So we enter the value 2 here. We want to know the corresponding probability under the standard normal distribution. Now click OK, and we get the probability. The two-tailed probability is 0.0455. And area to the right of 2 is 0.0227. That is one tail for the one tail test. This is the probability. And remember, for the two-tailed value, this is less than 5%. So that value 2 lies in the rejection region of the distribution. We can find that. So the p-value also is available. We can find out the p-value for all these distributions. Then we can have the distribution graph. For example, normal distribution. We can find the graph. Just click OK, and we get the normal distribution graph. And we can copy paste. If we want to record this, we can copy paste this onto the board. Now, suppose we want to find out the distribution of T. Say the degrees of freedom is 10. For 10 degrees of freedom, the T distribution graph. Click OK. We get this. So we can compare the normal distribution and the T distribution. See, compared with the normal distribution, the T distribution has, see, very high tail, very high tail. Here, this is not high tail. Here we have the high tail. Then the peakedness also is less than compared with the normal distribution. So we can have the different distributions like this. Chi-square, see the degrees of freedom. If the degrees of freedom is 2, then this is the distribution of chi-square. If the degrees of freedom is say 20, then see the chi-square distribution approximates normal distribution. As the degrees of freedom increases, we will get a normal distribution. So similarly, for other distributions also, we can have the graph. If we have a particular equation, then we can plot that particular curve corresponding to that equation. Now we can have parametric test, that is this test statistic calculator or non-parametric test. Only a few non-parametric tests are available here. For the test statistic calculator, we have a particular mean equal to a particular value. The null hypothesis mean is a particular value. We can give the sample mean if we have the information on this one. We can have the sum. We can enter the values and then clicking OK, we will get the result. Then we can compare a variance with a particular value, proportion also with that particular value. Then we can have two mean. We can compare two means. That is the t-test or the z-test. So we give the mean of sample 1, standard deviation sample 1, size of sample 1, then similarly for the sample 2 also. And then the null hypothesis is given, that is the mu1 equals mu2. That means the difference of means is equal to 0. Clicking OK, we will get the result. Now, if we have already entered the data, then automatically all these cells will be filled. And then we click OK and we will get the result. I shall show you one example later on when we enter after entering the data. Then similarly, we can compare two variances. That is, we can have the variance ratio test, F test. Here we have the T test for the means difference. Similarly, the difference between two proportions also we can find out. So only these tests are available here. Then we have the non-parametric test, very few are there. Now see, this is the Gretl console. Here we can enter our commands and do the analysis. Now I shall tell you about how we enter the data and other things. Before that, one more thing. We go to the file, open data. Then here we have the user file, that is the file that we want to open, our own file. Then Gretl has its own sample files. Click this one. Okay. So Gretl has used a large number of data sets in its guide, Gretl guide. You remember this one, Gretl guide, Gretl uses guide. So all the data sets used by Gretl in the Gretl uses guide are given here. So you can read the guide and then you can also you can do the same simulation like the Gretl guide. All the data will be available here. If you double click this one, then the data will be added here. So a large number of data sets are available. Similarly, this is the William Green's data. Only a few data sets are available which are freely available in the public domain. So those here, William Green's textbook data. Then all the data sets used by Ramanathan in his textbook also are available here. Now one word about this Ramanathan. He was the originator of this Gretl. That time it was not named Gretl, and this particular package he supplied on a floppy disk along with his textbook. Then after some time, Ramanathan gifted the entire package to an NGO, and now this Gretl is being maintained by that NGO. So Ramanathan's data sets are also available here. Now, if you go to Gretl website, there also you can find a large number of data sets. For example, data used by Gujarati in his textbook, then Scott and Watson, then a large number of data sets are available. You can download those data sets and install the data sets, and those data sets will become available here. So you can do that also. Now, anyway, here, okay, I shall use this Ramanathan's data 3.1, house prices and square feet. This is a cross-section data with 14 values, and I am double clicking it. Now the data are entered here. Price, sale price in thousands of dollars. Then square feet of living area. So these are the two variables that we have. So we know that price of a house is influenced by or determined by square feet. That is the house size. So we can have a simple regression using these two variables. Now, once we have entered this data, now let us go back to our tools and test statistic calculator. So I am clicking this test statistic calculator, and see, now here we have used variable from dataset. So I am clicking this one, clicking here, and either we can take price or square feet. So the data have been, information have been entered already here. Now we want to know whether suppose by some means we know the population mean price is say 320. That I am writing here. So our null hypothesis is mu is equal to 320. Now we click OK, and we get this is the critical value given. Estimated critical value is this one, and to the right of this we have the rejection region, not the critical value. This is the estimated value. Okay, this is the estimated value. Now see, we have the sample mean, then test statistic is given as minus 0.106. That is given by this one, minus 0.106. So we should have a critical value here. Suppose the critical value is 1.96 for the 5% significance level, then evidently we know that 1.96 is close to this 2. So the estimated value is less than this one. That means we cannot reject the null hypothesis. So that is our inference. We cannot reject the null hypothesis. What is the null hypothesis? The mean house price is $320,000. Now we can also consider the p-value. Usually this is the case that usually we do. We do not check the estimated value with the critical value. So we check the p-value. The p-value given is, for example, here if we are considering the one-tailed test, then it is 0.4586. Two-tailed also it is 0.917. Both are greater than 5%. Our alpha significance level alpha 5%. That means we cannot reject the null hypothesis. If the p-value is less than 5%, then we reject the null hypothesis. So this is how we do this. Now suppose we want to compare two means. This price and square feet, of course we cannot compare. I am giving this just for illustration. Okay. So if we click here, then the data will be entered here. Then we can click OK and carry out the test. So once we have entered the data, it is easier to do the hypothesis testing. Now, some other advantages are also there for grading. One is, suppose I am taking this price. We go to the variable, click variable. Here we can have summary statistics. Summary statistics are available in every packages. So this is, so here we have mean, median, minimum value, maximum value, standard deviation, coefficient of variance, and all these are available. But in addition to this, we can have a frequency distribution. Now see, those who are familiar with the SPSS and Stata will understand that how difficult it is to have a frequency distribution of the quantitative variables. Quantitative variables. Stata will consider only nominal variables, categorical variables for frequency distribution. Otherwise, it is very difficult to have frequency distribution of the quantitative variable. Price is a quantitative variable. But no problem in Gretl. We just click this one and we just specify how many wins we need. Wins means you know the frequency distribution from statistics already. That is the class intervals. Frequency distribution is reported in terms of class intervals and the corresponding frequencies coming inside each interval. So the bin is a class interval. How many class intervals we want? By default, Gretl has selected 5. If we want more, we can increase it, say 7. Then we click OK. We can have a bar graph and then this frequency distribution along with the midpoint and the frequency and the relative frequency and the cumulative relative frequency. And also a bar graph is given here also to show whether this has a normal distribution or not. Evidently, there is no normal distribution. So we can, getting frequency distribution of quantitative variable is very easier here. Just click, we get it. Now again go to the variable. We can have normality test and other things. Okay, we will do that later on. Then Gini coefficient. I think you are all familiar with the Gini coefficient. This is an indicator of inequality in a distribution. For example, income inequality distribution. The inequality in income distribution or inequality in consumption distribution and so on. So we click this one Gini coefficient. We have already highlighted price here, and that is why the Gini coefficient and the Lorentz curve of the price is here. You know, this is the Lorentz curve, and the area between these two curves is given in terms of the inequality ratio or the Gini coefficient. Now this area is much lower. That means there is not much inequality in this particular variable. Now see, I have taken the price only, okay. So the Gini coefficient is 0.147975. That is very low. We have very low inequality in the price level. You know, this red line is called the line of equality. That is, there is no inequality at all. The farther this green line from the red line, the inequality increases. So just with one click, we get the Lorentz curve and the Gini coefficient. And this Lorentz curve also we can copy paste onto the Word. Now in no other package, this Gini coefficient is available except of course R. In R, we have to download certain package, and then we can have the Gini coefficient, the inequality measure. Most of the inequality measures we can have in R, but in no other packages we can have this Gini coefficient. So these are some of the highlights of Gretl. Now I shall show you how we can have some graphical analysis. To have the graphical analysis, go to the view. Here we have graph. Then we have the XY scatter. We can have the XY scatter. Then we know price is a function of square feet, and Y is a function of X. So this is the independent variable. So our square feet goes here, and the price, the dependent variable, goes here. So we click this one, and this one we get the variables. If you want to remove any variable, then click this one and then right arrow. Now we click OK, and here we have the scatter diagram along with the regression line. The regression line is given like this: 52.4 plus 0.139x. So this we can copy paste onto the web. Okay. Now, how do we do the regression? To do the regression, we go to model. Here we have ordinary least squares. Click this one. So the dependent variable is price. The regressor or the independent variable is square feet. Already a constant is here. Now we can click OK, and we get the regression result. Constant is 52.35, and the square feet coefficient is 0.139. So this result we have already found along with the graph. Now here we have, you are all familiar with the R square, then adjusted R square, then the corresponding F value and the P value of F. So we have these values along with the standard error and the T value and P value of the estimates. Now the T value of the estimate constant is given 1.4. The corresponding P value is 0.1857, and that is. Now, how do we do the hypothesis testing in the context of regression equation? Constant is equal to 0. Equals 0. That parameter alpha equals 0. Alpha is the constant or intercept. That is equal to 0. If the P value is, then we will reject the null hypothesis. But here the P value is greater than 5%. So we cannot reject the null hypothesis. So the constant is statistically equal to 0, because that is our hypothesized value. Statistically, the constant is equal to 0. Now the coefficient of square feet is 0.139. The T value is given 7.4. The critical value is 1.96. So the estimated T value is greater than the critical value. So we reject the null hypothesis. What is the null hypothesis? Same as our constant case. The null hypothesis here, the coefficient is beta. So we postulate the null hypothesis as beta equals 0. That means if beta equals 0, then there is no relationship between price and square feet. That is our hypothesis, null hypothesis. That we are rejecting because the T value is estimated T value is greater than the critical value at 5% level, that is 1.96. Similarly, the P value. See this P value, whenever we find E minus, then take the P value as equal to 0. So here the P value is equal to 0. That is why we have 3 stars. If the P value is less than 1%, then we will have 3 stars here. That means it is highly significant. So the p-value is 0. That means that is less than 5%. Our usual conventional p-value, conventional alpha, that is level of significance. So the p-value being 0 less than the alpha equals 5%, we reject the null hypothesis that beta equals 0. That means there is a relationship between price and square foot. So that is the idea we get. Then what are the R square? R square shows the proportion of the variation explained by our regression. Here it is 82%. 82% of the variation in price is explained by our regression model. That is explained by one variable square foot. 82%. Remaining only 18%. That 18% goes to the residual. Then we have the F test. F test is actually the model significance test. And in the case of a simple regression, this is equivalent to the F value is equivalent to the square of the T value. That is square of 7.407 is equal to 54.86. So whenever we have the F statistic with 1 and another degrees of freedom, that is one type of degrees of freedom is 1. That is, we have only one independent variable. Then the F statistic is the square of the T ratio. And in this particular case, our null hypothesis is beta equals 0. That is the same as our T test, beta equals 0. So we have 54.86 and the p-value is given, p-value is 0. That means the model as a whole is significant. Anyway, we have only one variable and its significance we have already seen using the T test of the p-value. Then adjusted R square is the R square adjusted for the degrees of freedom. And we have different degrees of freedom here. And adjusting for the degrees of freedom, the R square now is less than the usual R square. Here we have 0.82, here it is 0.8, maybe 1.81. So these are the relevant estimates that we need to explain, we need to discuss in the context of a regression equation. Now I shall take up a multiple regression case, and for that I will use another data set. I'm taking a data set like this. Okay, this is a time series data set. T is given 1, 2, 3, 4, 5. Maybe starting from 1960 January, we get monthly data. We have the variable consumption, then income and inflation. And this is the wholesale price index. The inflation is calculated from the wholesale price index like this. So we are formulating a multiple regression of consumption as a function of income and inflation. So we are going to enter this data in Gretl, and then we will do the multiple regression, and then we will see whether our model is adequate or not. If the model is not adequate, then what we have to do, how we can arrive at an adequate model, all this we will explain now. Now, if your data set is on the desktop, or if it is something like this, okay, yeah. So here I have the data set open. So one way of entering the data in Gretl is by dragging and dropping it. in the Gretl window. That is, here I have the data, workshop data. So this I am clicking like this. So you can see how I am drawing it, right? And then I am taking it into the Gretl window, and then I release the button, my mouse. Now we have already in Gretl memory, there is already a data set. So the Gretl will ask, will tell us that if you open a new data set, then the old one will go. Do you want to proceed? We say yes. Then the spreadsheet, import spreadsheet will be available here. I want the second sheet. So I click on this one, second sheet, income, consumption, inflation, and then click OK. So we click OK. Now the Gretl will ask us whether the given data is cross-section or time series or panel data. Do you want to give the data a time series or panel interpretation? We have a time series data, so we say yes. So we say yes. So what type of data set? We have time series. Click this one and click forward. Now, what is the frequency? Annual, quarterly, monthly, weekly, daily, hourly, and so on. So we have a monthly data, so we click this one, monthly data, and you click forward. Then 1960 January I have taken, but we can change this one by increasing like this or decreasing like this, or we can directly type it here. Directly type it here. I am not doing anywhere doing here. I am keeping it 1960 January. So click forward. So it is given monthly 1960 January to 1973 March. We say apply. Click apply. So we got the data set here. Okay. Now earlier you may have noticed with the cross-section data, when we click the variable, these were not visible. Now these are all visible. Okay, now these are all visible. We can have the type series plot. Then we can have unit root test, parallelogram, and also all these. And this we will consider when we come to the time series analysis. Anyway, for the consumption, we can have a time series plot. We just click this one and we get the time series plot here. So just one click and we get the time series. We can of course edit it. Right clicking, we can edit this one. So, and then we can copy paste this onto the Word. Okay. Now, how do we do the multiple regression? Now, another way of entering the data, this is dragging and dropping. Okay. Another way of entering the data is as usual with the other.
Sir, a small question I just want to ask here. Hello.
Hello.
Sir, what is T in the data set?
What is the
T, the fifth variable which is shown at the last in the data set window?
No, I cannot hear. Can you repeat it?
I'm saying, sir, what is the T? What is the T in your data set? It is there in the,
He is asking about the T.
What is the
T variable in the data set? The fifth variable shown in your data set window, right?
variables? See, these are the variables: consumption, income, inflation, WBI. Oh, this T. Oh, this T is time.
Yes.
T we use for time. See, 1, 2, 3, 4, 5, 6, 7, 8. So this is the time
Thank you.
Okay, this is the time rate T. Okay, I should have written time. Okay. So where are we? Okay.
Another way of entering the data set we are discussing.
Another way of entering the data, right? Now we go to the file here and then open data, user file, click this one, then we will be led to this one. Okay, so where is our data? If your data is on desktop, click this desktop. So here I don't think my data. Now we have to change this Gretl data files. This one. Say we have Excel files, Excel SX. So change it into Excel SX. So all the data Excel data sheets will be here. So the corresponding one we can click and then we can say open, and then the data will be open there. So this is another way of opening, just like any other package. For example, Stata. We do in Stata we are importing the data. In SPSS we are opening the data. File open and so. We are going like that. But in some of the packages we can drag and drop the data like I have shown here. For example, Gretl, it is possible in SPSS. We can drag and drop the data in SPSS. In EVs also, we can drag and drop the data. But in Stata, we cannot do that. And in R, of course, we have to import the data. So that is the case. Okay, now let us do our regression, multiple regression with the consumption, income, and the inflation. We go to the model as usual, ordinary least squares. Our dependent variable is consumption. We enter that and click this one, set as default, so that we can have different versions of this regression, so that the consumption will remain here. Now we enter the two independent variables, income and the inflation. Click here. We have income, inflation along with the constant. Now, if you have any doubt, you can go to the help and see what is given there. Okay. Now we click OK and we get the regression result here. Constant, income, and the inflation. Now the standard errors are given. Then the t-value. How do we get the t-value? T-value we get by dividing this coefficient by the standard error. Then we are getting this one. For example, 1.15 divided by this 0.024, we get 47.4, the t-value. Now see all the t-values in absolute value are greater than 2. That means they are highly significant, much higher than 2. So that all the p-values are 0. See, we have E minus 10, E minus 94, E minus 24. These are all very small, or as good as 0. And that is why in all the cases we have the 3 stars. Now, whether our significant is significant or not is easily identifiable in regression research. That is, if it is significant, then there will be at least 1 star along with a coefficient. So at least 1 star. 1 star means 10% significant. 2 stars, 5% significant. 3 stars, 1% significant. No star means that particular coefficient is not significant. So here all the 3 are significant. So just to one look, we can find out whether all the estimates are significant or not. Just to one look, just to see whether there are any stars. So we have 3 stars for all the estimates here. So all the estimates are highly significant. Okay. Now don't write when you discuss this. Don't write that stars are there, therefore they are significant. That part we have to give it in terms of the p-value. All the p-values are 0. So the significance is very high. So here we have the R square 0.94% is explained. F value, the P value is 0. So the F value also is significant. Now, in addition to this, do you find, you can see the results, right? Is there anything that you are familiar with here? Any other measure? Can you tell me? If I expand this, it will remain like this only. So the double-bottom statistic here is 0.6. That is much less than 2. That means there is first order positive autocorrelation. So that means at least one of our wireless assumptions is violated. No autocorrelation assumption. That also only first order. So that assumption is violated. Therefore, our model is not adequate, even though all the estimates are highly significant with very high R square value, very high F value. This model we cannot use because this model is not adequate. That's the problem. This model we cannot use. Now, what we have to do? Now, we know, in addition to the first order autocorrelation, there may be some other problems also. So first we have to test whether all the assumptions, important assumptions of OLS are satisfied by this particular model or not. That we have to find out. Now, this test. So here, can you see this test button? Click this one, and here we have all the tests. And here we have Ramsey's reset, heteroskedasticity, normality of residual, then autocorrelation, then ARCH. This also we have to check. We have to check whether there is any ARCH effect, autoregressive conditional heteroskedasticity effect in the framework of a time series or financial time series. We have to check all these assumptions, starting with the specification error, then no heteroskedasticity, normality, autocorrelation, and ARCH. So all these we have to test. Let us start with the Ramsey's reset. Click this one. And it is always better we go by the default one, that is squares and cubes, because all the possible non-linearities are included here. So we click OK, and here we have the results. Go to the last line. Last line reports the p-value. See whether the p-value is greater than 5%. If the p-value is greater than 5%, then the model is not suffering from that particular problem. I told you, for all of our model adequacy tests, the p-value must be greater than 5%. If the p-value happens to be less than 5%, then the model is not adequate. So here, what do we find the p-value with our reset specification test? See here we have E minus. That means the p-value is 0. P-value is 0 means it is less than 5%, our conventional alpha significance level. So we reject the null hypothesis of, what is our null hypothesis? No specification error. We reject that null hypothesis. If this were greater than 5%, then we would not reject the null hypothesis. That means the model would be adequate. But that is not so. So we have specification problem in our model. Now, once we have estimated this test, Gretl has an advantage of reporting that test below the regression result. Research test for specification along with null hypothesis. If you do not remember the null hypothesis, don't worry, it is given here. Specification is adequate. That means there is no specification error. The p-value is 0. So that means the specification is not adequate. So that is one case. Now again we go to the test. Next one is heteroskedasticity. I told you we can have the White's test, and here this is the generalized White's test, and it is very stringent one, very strict one, stronger one. So we use this one White's test. We have Bruce-Pagan test also, that also we can use. Anyway, we are going by White test. And what do we find? The last line reports the p-value. The p-value is 0.938. That is greater than 5%. Greater than 5% means what? What is our null hypothesis? No heteroskedasticity. That is homoskedasticity. That we do not reject. So I told you, even otherwise, if the p-value is greater than 5%, then our model is adequate. So here there is no heteroskedasticity. This result also is reported below the regression result here. White's test for heteroskedasticity with the null hypothesis. Heteroskedasticity not present. The p-value is 0.94. Therefore, we do not reject the null hypothesis. There is no heteroskedasticity. We go to the test again. This time, normality of residue. Click this one. Now the p-value is given here. See, within square brackets, we have 1.1967. And 0.1967 is greater than 5%. That means, then we know any p-value greater than 5% means our model is adequate. So there is no normality problem. Our residuals are following normality assumption. Click this one. We have another frame here with the interval, that is the frequency distribution, and then we have the test for null hypothesis of normal distribution. The chi-square test, you remember chi-square test with the 2 degrees of freedom. This test is our JB test, Raki-Berra test. P-value is 0.1967. So, and this result also is reported here, normality of residue. The p-value is 0.19. We do not reject the null hypothesis that error is normally distributed. We do not reject that. Now again we go to the test. Then we have the autocorrelation. Click this one. Now we know autocorrelation is in terms of different laws. We have first order autocorrelation, second order autocorrelation, and so on. So now here we are using monthly data. Therefore, Gretl has selected log order for test as 12. That is for 1 year. If we have annual data, then Gretl will use a log order of 1. If we have quarterly data, then Gretl will use the order as 4, and so on. Anyway, we can use this 12 as such. So we click OK, and here we have the result. Come down. We have 3 tests. All these 3 tests are the Bruce-Pagan test. Bruce-Pagan Godfrey test. Bruce-Pagan Godfrey test. In all the cases, the second line gives the p-value. Here, this is the p-value. This is the p-value, and this one is the p-value. We have the p-values here. And what are the p-values? The p-values are all the p-values are less than 0. That means what? We are rejecting the null hypothesis. What is the null hypothesis? No autocorrelation. That we are rejecting. That means there is autocorrelation if up to the 12th log. Up to 12th log, not just 1 log, just like our Darwin Watson statistic. So this result, one of these results is reported below the regression results, autocorrelation with the null hypothesis, no autocorrelation, and the p-value. Now we have one more, that is about the arch effect. We click this arch. Here also we have to give the lab order. We are giving again 12, the default one. Click OK. And here we have the p-value. The p-value is 0.0003. So this is less than 5%. That means we are rejecting the null hypothesis of no arch effect. That means there is arch effect also. Autoregressive conditional heteroskedasticity also. So this result also is reported here. We have all these cases. So is our model adequate? Which are the assumptions not satisfied or violated? The specification error, no specification error assumption violated. No problem with the heteroskedasticity, no problem with the normality assumption. But there is autocorrelation. There is arch effect also. So in 3 cases, our model is not adequate. So we cannot use this particular model. We have to re-modify our model, re-specify our model. Now, we have, is there any other assumption we have? Do you remember?
Sir, sir, in autocorrelation, there were 3 results. So if out of the 3 results, 2 are significant, maybe 1 is not significant. Then which one we will take?
Sometimes it can so happen. Usually it will not. Usually it will not. Sometimes only it can happen. So
okay.
So we can go by any one result. Doesn't matter. Okay?
Yes, sir. Yes.
Okay. Now any other assumption that we had used? Any other assumption?
Sir, stationarity we will not check.
No. Stationarity comes in time series analysis, not here. We are not. But there is actually a non-stationarity effect here that I shall tell you later on after this. So any other
multicollinearity we have not checked.
Which one?
Multicollinearity. Gauge.
Yeah, multicollinearity. Now remember, multicollinearity indicator or test is not a statistical test. That is why it is not appearing here. But the indicator we will get if we go to this analysis. Go to the analysis. Now here you can see collinearity. Okay. This is multicollinearity. So click this one. Now I'm not going into going into all these lambda values and other things. That is the conditional index and other things. But then the variance inflation factor only. And if you do not remember about the properties of the VIF, then no problem. Gretl will help you with this. Gretl says minimum possible value is 1 and values greater than 10 may indicate a collinearity problem. Here we have 2 variables, income and inflation. These are the VIF values, variance inflation factors. They are not greater than 10, right? They are close to 1. That means there is no problem of multicollinearity. Got the idea? Okay? Right. So I am clicking this one. Okay, leave it. Now I am going back to our regression research. I told you about a non-stationarity problem. An effect of non-stationarity problem appears here in terms of this high R squared and low Durbin-Watson statistic. Now see, here we find R squared greater than the Durbin-Watson statistic. Got the idea? If we have a situation like this, then the corresponding regression is said to be a spurious regression. Spurious regression. So this is actually a spurious regression. Spurious regression means it is not a valid regression. This is not a valid regression. So hereafter, be very careful with the time series regression and check the R-square value with the Durbin Watson. If the R-square is greater than DW statistic, then the given regression is a spurious regression. So here we have a spurious regression only. And that is because of non-stationarity, as we will see later on. That is when we come to the time series class. Here, how can we match these problems? That is, how can we have an adequate model from this one? And this is what I am going to do now. So to get an adequate model, we see out of all these problems, the big problem is autocorrelation. So whatever problems you have, first match the autocorrelation problem. So by mending the autocorrelation problem, most of the other problems we can solve. So how do we repair, or how do we do the remedy for autocorrelation? I have told you about that quotient workout method, right? Unfortunately, in most of the textbooks, the discussion ends with that particular equation. But if we proceed from that particular equation, we can arrive at a very simple model, which is called an ARDL model, autoregressive distributed lag model. This autoregressive distributed lag model will solve in most of the cases the autocorrelation problem. That is, what we have to do is this particular consumption function now we are re-specifying in terms of an ARDL model, autoregressive distributed lag model. Now, autoregression already you know. Autoregression means in the regression we have a lagged value of the dependent variable. That is autoregression. Then what is this distributed lag model? In the distributed lag model, we will have the lagged values of the independent variable. So in an ARDL model, we will have the lagged values of both the dependent and independent variable. So this is what we are going to do now. We are going to estimate an ARDL model. And this particular model technique is known to be known as general to specific modeling. That is, we are starting with a very general model including all the lags of all the variables. And then we run the regression. If there are any insignificant lags, then we will reject those lags and rerun the model without those lags. Then again check, is there any insignificant variable? Remove that. Again run it. And finally, we will come to a model where all the lags and variables are significant only. That is the specific model. So we are coming down from a general to a specific model. So this GTS, general to specific model, is given by David Henry of London School of Economics, and therefore this is either known as LSE methodology or Henry's methodology. So this is the methodology that we are going to do here. So we go to the model and re-specify the model ordinarily squares with the lag of all the variables. That is consumption, income, and inflation. So to get the lag, we go to this lags. Can you see this button lags? This one, right? So we click this one, lags. So by default, all the independent variable we can give the common lag. Say I am giving 2 lags, 1, 2, 2 lags. Then we have to give the lag of the dependent variable also. Lag from 1 to 2. I am giving common lag 2 for all the variables. So this is my general model. Click OK. So all the variables are here. Now click OK, and we have the regression result here. And just to one look, some variables, some estimates do not have the star. What does it mean? They are not significant. If they are not significant, then we have to remove those variables. Which are the variables not significant? Income with the lag 2. Income with the lag 2. Then inflation with the lag 1 and inflation with the lag 2. Then consumption with the lag 2. Okay. So now what we are going to do is we have to remove these insignificant variables. I think I shall include inflation minus 1 and remove inflation minus 2. Just let us see what will come. So we are keeping it here. Go to the model again, ordinary squares. What we have to do? Remove the second lag, all the second lags. Income, second lag. Inflation, second lag. And then run the regression. Click OK. Now what do we find? Inflation minus 1 is not significant. So we go to the model again, rerun the model, remove inflation minus 1, and then click OK, and here we get the model. What do we find? All the variables are significant, highly significant. Now what we have to do? We have to see whether there is any problem with our OLS assumption. So that means let us start with the, see now the R square is 0.99. R square has increased highly. Now what about the rho? The autocorrelation coefficient 0.022. It is close to 0. So does it mean that there is no autocorrelation? What about the Durbin-Watson statistic? Can you tell me the Durbin-Watson statistic? What does it mean? Anybody?
It should be close to 2.
It is close to
2, then there is no autocorrelation.
If it is close to 2, then there is no autocorrelation. What is the value here?
0.3002.
See, now just to see, is it Durbin's D statistic or something else?
Durbin H.
Because Gretl knows that we are doing an auto regression. Or if we are doing an auto regression, then DW statistic, D statistic is not reliable. Gretl knows that. In such cases, we have to use Durbin's H. And Durbin's H value is 0.3. And this 0.3 is less than our critical value. We know Durbin's H follows a normal distribution, standard normal distribution. So we have to compare this with our normal distribution critical values. That is 1.9645% significance level. So 0.3 is less than 1.96. That means we cannot check the null hypothesis of normality assumption. Normality. That means, oh, sorry, no autocorrelation. We cannot reject the null hypothesis of no autocorrelation. First order autocorrelation. Again, you remember Durbin's H deals with the first order autocorrelation again, like Durbin's D, Durbin-Watson's D. First order, there is no first order autocorrelation. Anyway, let us see other cases. Go to the test. We start with the Ramsey's research. Earlier we had a problem with the Ramsey's research. Click OK. And what is the probability? The last line, the probability is 0.328. That is greater than 5%. Now there is no specification problem. There is no specification problem. That is one thing. Then now this is reported below the regression result. Go to the test. Next we have heteroskedasticity by test. And earlier also we have found that there is no heteroskedasticity. Here also there is no heteroskedasticity. The p-value is 0.33. So no heteroskedasticity. Then go to the test again. We have normality. Earlier we have found that there is no problem with the normality assumption. Here also the probability is 0.41. So there is no problem of non-normality. This also is reported here. Then we go to test. Now we have autocorrelation. Click autocorrelation. We are giving 12 log. Okay. And come down. We have the 3 tests. All the 3 tests, the p-value 0.563, 523, 0.25. That means all the p-values are greater than 5%. That means there is no autocorrelation up to the order 12. So there is no autocorrelation. Okay, I shall just remove this. Okay. So this also is reported here. Now arch effect. Earlier we had the arch effect. We are giving 12 log. Okay. Now the probability is 0.781. That means greater than 5%. All the p-values are greater than 5%. So our model is significant. No, sorry. Our model is adequate now. See the p-value greater than 5%. Greater than 5%. Greater than 5%. Here also greater than 5%. Greater than 5%. In all the cases, the p-values are greater than 5%. So our model is adequate. So we have to use this result. This is the adequate model. So we have to use this model for forecasting. So this is how we do the regression using OLS. If we use OLS, then remember we have to see whether our model is adequate. We have to test for all the assumptions. If there is any problem, then we have to mend that problem. And
Sir, it can be do both for cross-sectional and panel also. All the tests for both cross-sectional and panel also. For panel also, we can check all this assumption.
Some of the tests are available for the panel data.
Okay.
Some of the tests, not all. So this we have to do. Now remember, among the problems, if autocorrelation is there, then first repair that problem. And here in our case, by removing the autocorrelation problem, we have removed all other problems. Now one more assumption is remaining, that is our multicollinearity. So we go to analysis. Here we have the collinearity. Now can you tell me whether there is any problem with these values?
Income is greater than 10.
So the values are all greater than 10 except inflation. So that means there is some severe multicollinearity problem. So what we will do? What we will do? Can we omit any variable? Can we remove any lag from this? If we remove a lag, what does it mean then? All these variables are relevant. They are all highly significant. And our model is significant, except in this case. We have the differential impacts of all the variables. So what we will do? Go back to the initial one. If we remove the lagged values, then what we will get? Our first result, this one. See this one. Is this model adequate? This model is not adequate. That's the problem. So if we remove these variables, income and income minus 1 and the consumption minus 1, then we will have a problem of getting an inadequate model. So what we have to do, we will go
Just
for the, yeah, we go
Just
for
ignore
the
the multi-column.
yeah, we go for the last remedy. That is, just ignore this problem. Just ignore this problem. So this is how we do the regression and the model adequacy test. Along with this, you also read my working paper that the tradition is questioned. And now, if you have any doubt, now we can go for the
Sir,
discussions.
ARDL model we can do with any number of variables. Like
Oh.
you have taken 3, so I can take 5, 6, any number.
Oh yes, depending upon the sample size. If we have a large sample, we can include all the variables theoretically relevant. Okay, not going by the kitchen sink approach. That is putting all the vessels in the kitchen sink. We cannot do that. So we have to be rational. We have to be choosy. So choose the variables according to your theoretical framework. If a variable is theoretically relevant, that must be included. And if your intuition, even if there is no theory, if your intuition says that this particular variable is significant, you can include that and see whether it works or not. You can do that.
Thank you, sir.